Hello, welcome to video 6 in this series. We're now going to start looking at React hooks. So if we compare where we've got up to so far creating our to-do app and the final result, if we look at the final result, there are a bunch of things that all start react.useRef, react.useState, and down here we've got react.useEffect. So all of these functions that we're importing from React are all called hooks, and it's just a convention that they always start with the word use to kind of make them stand out. So if we jump over to like the React docs, most docs always start with this useState hook, and I'm actually going to start with the useRef hook. Even though it's less common, I think it's conceptually much simpler to understand, which should help then understand useState. So let's take a look at useRef first. So refs in React can be used for a whole bunch of things, but what we're going to do is we're going to look at using them in the context of accessing the DOM. So right now in our code, when you click this button, so if I type in here, I want to bake a cake, when we click the button, what we want to do is take the current value that's been typed into the box, into the input field, and then add that into our state so we can list it as a to-do. So the state of what's been typed in here, that right now, there are other ways to do this, but right now, the only thing that knows about that state is the actual real DOM element, the real DOM element. We've got our kind of virtual DOM here, which is just creating a React element to tell React there should be a real input DOM element here when it comes to rendering this component. But this bit of the input here is never actually going to know what it ends up creating. This is just kind of like a recipe. So, and this works. If I do this, it goes off and it gets the element using its ID. That's a bit fragile because if I put a typo here, nothing's going to immediately error, but now it's not going to work. If I type something in, now it errors because this returns null, and so we get a problem much later when the app's actually running, which is a bit annoying. And also it's not very scalable, because how do I know this ID is unique if there are multiple to-do apps on the page, or there's just lots of React elements? You need to come up with a unique ID for all of them, and that can be, that's no fun. So we want to get away from just using strings to refer to things. So let's use a hook. So what we're going to do is we're going to say that the input element ref react.useRef, and we now have some ref thing. And what we can do with that, actually, first of all, if I just log that input ref. So if we have a look at what's logged, all it is an object with a property called current, which is currently undefined. And that's the only thing it has. Really nothing special about it at all. You can almost imagine this just kind of giving us an object that looks like this. It's not exactly the same as that, which is why we're using hooks, but all it's giving us is a value that looks just like this. Nothing special about a ref more than that. So, and what we can do with this ref is, and so instead of this ID here, we're going to say ref is that input lref. So we can use that ref object and then use that as the value that we assign to this ref attribute. And you may have seen it from earlier videos that this ref attribute is kind of a bit special. So I just take this up here, log, when we're creating those. So when we create this React element, so let's pass in like another property here, like foo is 1. So props, foo has been taken. So this part of the attributes has been taken and put into this props object. But ref has been treated slightly differently. Ref has been put in a slightly different part of the React element. It's been put up here, ref up here. So that's a bit, that's kind of just a hint to us if we look under the hood that this ref isn't just a standard prop that's being passed down, that React immediately knows to treat something called ref slightly differently. Let's just get rid of that. And if we, so what that's going to do is that when React actually comes around to taking this template, this recipe, and actually creating the real DOM from it, it sees this thing, this input element has this ref object stored it as part of it. And what it's going to do is then actually going to set that ref.current to the value of the DOM node that it ended up creating. So here, instead of going off and searching the DOM for the element, we can actually do input elmref.current. console.log that input elref in here. So when I type in here baked cake, we get a warning just about the map stuff. We don't have to worry about that. Here, so this is us logging that ref, which earlier, it just was an object where current was undefined. Now current is pointing to that actual HTML input element. So we actually have access to the real DOM now, which is, and I shouldn't do this, it's refreshed. And as we can see, that is working. So this is really useful. So we've somehow asked React, I want to use a ref, and we can now pass that through to this element, and so we can actually access the real DOM. So we've got rid of that kind of magic string now. So before, when I spelled that string wrong, I didn't get an error until we used it. Whereas now, because I'm actually accessing things all through just JavaScript variables, if I spell this wrong here, that's now something that's much easier to detect because there is no variable with this name. So we can spot, it's going to be much harder to not link these things up. And also these things, if it's not obvious, there can't be any conflict. If there's some other app running somewhere on the page, there's no way that this ref is going to accidentally refer to the wrong input somewhere else on the page or some other element, because this object here is just being created just for me inside this app component. I'm using it here, then I'm accessing it here. It can't leak outside anywhere. So our code's better, but this has possibly been quite confusing on how is this working? Like what exactly is this doing? Why is it people may be either thinking, why is this special? How is this? Maybe they've heard like hooks are complicated. Hooks are something special. How is this any different to not using hooks? Or people are kind of thinking, yeah, this does look magical. Either way, there's something to kind of dig into here. So first, the people that think, I can't see anything special that's happening here, in some ways you're right. So there's another way to, if we don't use hooks and we just create this object ourselves like this, though that's not technically, you're not really supposed to create refs like that, just because it kind of leaks an abstraction slightly. Another way is just to say react.createRef, which is, for all intents and purposes, is just creating one of those objects for us. But if React ever wanted to add extra things to that ref object, that would be, it's going to work because we're asking React to create them. Whereas if we're creating them ourselves, potentially that could break in the future. But let's kind of ignore that and just show that if we literally create this object ourselves, does it still work? Yes, it still works. So there's kind of nothing going wrong, and this is working, but it's kind of working just because we're not doing anything more advanced in the component. So what's happening is this is running every time. Console.log, like app x executing. So whenever we change our state, we're saying render and we're telling the whole app render again. We're calling react.dom.render down here, render the whole app again. So every time it renders, we're creating a new ref, and we're always then passing a new ref, and then it's going back to being undefined, and creating a new object, a new ref where it's undefined, and then React's taking that latest one we've passed and then setting it to that input element. Even though it is always the same input element, the point of React is that it can see that this template here isn't changing, and there's always a input field here. So it's only creating the input field once, but we keep creating a new ref and keep assigning that ref. So it's working because our function here kind of can always see the most latest one. The latest one is always assigned by the time this runs. But if we're doing some more advanced stuff, this could go a bit wrong if you're passing this ref to a closure in JavaScript, and then you don't create that new function when the app renders. It could then end up having access to an older ref from a previous render and not having the most up-to-date one. So we don't want to be creating a new ref every time. It's kind of hard to demonstrate exactly why with code right now, because I say the app's not complicated enough to show it, but you have to believe me that there are issues if creating a ref. We want to access this over time, the exact same thing. So we could say, let's move this up here so we only create it once. So now, again, this will work. But the problem here is that now there's just one ref up here. And if I wanted to use this component twice, they would both be accessing this same ref variable. So we can see that now being a problem. If down here, let's say, 2 to-do apps. This maybe more makes sense if it was like a button or something, multiple buttons. But let's say you wanted 2 to-dos. So these two kind of separate places where we've got this app component, which we want them to be, we want them to have we want them to both work. They're now both sharing this ref. So the ref can only point to one of the input fields. So if I type into, and it's probably referring to the second one, because that would probably be, is going through and creating them in order, creating the top one first, then creating the second one. So if I type in to this one and click add, nothing's working because that ref's actually going to be pointing to the second one. if I type into here, second field, and click add. So they're sharing the same state because the state has the same problem right now because we haven't got onto the useState hook. Is the things that live up here are shared. So when I type into this one, it's like more distinct. When I click add on this, when it's trying to refer to the input, that input field is referring to one of them, and right now it's referring to the second one. So that's a problem. So we don't want the things to live up here. We want them to be unique to each one. So if I put that back into here, now they're showing the same state, but the two can, it'll read the correct input field based on the one next to the button that it's referring to. So the button and the input field ref are in sync. But yeah, we're now back to the problem of we're creating a new ref every time, which can lead to other issues. So what we want here is a way that we can just create this ref once and then just keep using that same one every time that kind of component updates. So that is kind of what the hook gives us. So if I go here and put this back to the hook, React.useRef. So this is now actually going to create a ref, but then as this app then runs multiple times, it's then going to give us back the one that it's already created. So if I up here, let's go back to just having one app. Previous ref. Previous ref equals input ref. Console.log. Is that the exact same object as the previous ref? So for those that don't know, if I do this triple equality on objects, I'm literally saying not do these two things look the same, but are they literally the exact same value? So that with an object, so if I mutated this object, you would also see the same change here because I'm mutating the same thing. So if I then, we got false first and then true. So the first time it's false, which is expected because the very first time there was no previous ref. So previous ref is going to be undefined, and then we're going to have a ref, and that ref is not equal to undefined. But then as we then continue to go along and do more updates, we're always getting true. So useRef is giving us, it's creating a ref, but then as this component updates, it's just giving us the existing one. So we can also see that if I create, this again is where we're going to see the power of hooks. So if I want a second ref, I just have to call useRef a second time. And are they the... Now let's compare them like this. So we get false, and then as the app updates, they're still false. So I'm creating two refs, but they're not the same. So each time I call ref, I'm saying to React, create me a ref, and now I say use ref, and React knows that I'm calling use ref a second time. So this is a separate call. So it's going to treat these two kind of use ref requests separately, and it's going to create me a second one. So these two are two completely individual objects with kind of no relation to each other, apart from the fact they're both being asked to be created as part of this app component. So now if I say second ref dot current, would it let me use the new syntax of so if it's no, it isn't currently okay, I can't use that syntax yet. So I'll say, so actually what I can do, let's do this. So the value I pass here to useRef is actually just the starting value of current. So if I do here console.log second ref, so normally it starts as undefined, but because I'm saying 0 here, I'm saying start.current with the value 0. So if I say instead start with 9, it starts with 9. If I don't pass anything, it starts undefined. So I'm saying start with 0, and then second ref.current, increment it. So you shouldn't really mutate refs like this, just in the middle of your component, because components are supposed to be pure, they're not supposed to have side effects, and that's why we're going to get later on to our use effect on when we actually want to do things like mutate stuff, but just for demonstration purposes. So it starts at 0, and then every time I run this, that value has just been incremented. So again, that kind of proves that React's always giving us the exact same object back as last time, because the value is incrementing. So if it was creating a new one every time, it would keep resetting back to 0. It would have no knowledge that I'd set it to 3. I'd incremented it. It wouldn't kind of know that. It'd just keep creating me a new one. So in some ways you can view this as state, in that it's now giving me something that I can store values on, and I can change that value, and I can kind of, as the app updates, I can see what that value was from before. I'm not starting from scratch every time. But it's very different from state in that it doesn't, I'm still having to call react.render, like setting, doing current. So here, if I tried to use this ref instead of our state up here, so let's say our like list of to-dos is like this. Let's say state ref. And then we say state ref dot current. State ref dot current. So when I update that, so if I do here, like if I try and set it, state ref dot current dot concat, let's create a new array. I'm just going to push want too many brackets. So setting that current value isn't having any impact. It's not actually causing the DOM to be updated. If I have a look here, state ref dot current. So I need to buy flour. So we can see here, okay, there's now a thing. It says buy flour, and then buy eggs. So it is updating it, but that's not triggering the actual app to render. There's nothing's listening to this current field and then reacting to it. This would work if I tell React, hey, I've updated this, now render. but flower but x. So we can use this. So in some ways this is an improvement, because so before when we had two to-do apps, the two were just sharing the state variable up here, whereas now they aren't sharing that. So it means if we do have two separate, and these things are now isolated. I want a second to-do app. So now I've got two to-do apps, and they each have their own state, completely independent. So it's an improvement, but yeah, we're still having to tell React, hey, render the whole app again, because some state has changed, even though that state is kind of inside React. React's unaware of it changing. It's just given us an object and then it's completely up to us what we kind of do with that object. So one thing we can do with it is use it here as a place for storing the real DOM node kind of references. We can also use them for storing bits of state ourselves that we don't want to actually have any site, like we don't want it to trigger React to do anything. We just want to kind of store some values in there ourselves. We want to kind of squirrel something away. So they are really useful, but yeah, they're not great for state that you actually want to trigger an update, and that's what's going to get us onto react.useState. Hopefully for the people that were previously thinking they couldn't see anything magical happening with hooks, and now in the camp of, okay, yeah, there is something kind of special going on here that they possibly haven't come across before. So that means we can now address, what is this special thing that's going on here? So normally when we think of functions, we think of them, I kind of saying either two things normally a function would fall into of, given some input, it's going to calculate something. So if I have a function add two numbers, I give it those two numbers and it adds them back. So that would be like completely stateless. So if I have a function like add x, y, return x plus y. So these functions here are obviously not like these types of functions, because they have some memory in that when we call it multiple times, it's giving me back the same thing. So that's you could think of those like, it's like I'm calling a method on something that has some state. So if I had some class my library, I would say use a thing, and then it could here have like a private cached thing. It's undefined. So like if it's not the case that there's a cached thing, then this dot cached thing equals. So this creates something that looks like a ref. If it's not the case that this dot cached thing, I'll return this dot cached thing. So here we have a method. So I have my so here I say so I want a new lib, and if I do l dot use a thing, l dot use a thing. So the first time we call this, lib's not going to have a thing created. This will be undefined, so it's going to create one and then return it. And then the second time I call it, it's going to see that, oh, I've already cached a thing, and now give you that returned thing. But that's, again, can't be what's happening here, because I'm calling this twice. But I'm getting back a different thing the 2 times. So it's giving me a different thing every time. But then in the future, I come through and I call these 2 things again, and it's giving me back the thing they gave me before. So it's a bit like I say use a thing, and then this gives me, so object A. Then I call it again, and it says, okay, I'm going to act like nothing was cached somehow, almost like it's created a second thing, like L2. And now that's giving me a whole completely new thing. But then later on, like some time passes, and then this function runs again, and then we say call this thing. So it's, and now I'm now saying use. So I'm calling use a thing, but it seems to like remember which one it was related to. So it knows, oh, you're not calling that first one twice. Even though I'm saying react use ref, it's going, oh, you're actually, this one is referring to this kind of cache, and the second call is referring to this second one. So that's really odd that we can write something that's like keeps calling the exact same thing. So if we kind of zoomed out, we've effectively just called the function 4 times if this rendered twice. So we've called it once, we've called it again on the when this is first rendered, then when it updates and it renders again, and we're calling it a third and a 4th time. So we're calling this method 4 times, but getting 2 different results, and they're interleaved with each other. So that is odd. Like most libraries don't work that way. And so the way React is doing this is, if we remember from our last video, the real key thing that's enabling this is that React is calling this app function. We aren't calling it. If we try to call this ourselves, React is not going to be happy about us calling these things. Let's get rid of this. So if I just try to here call app, which we're now getting invalid hook call, and if I get rid of those hooks, actually let's just replace those with create ref. Create ref. Create ref doesn't work that way. State ref. Okay. So if I don't use hooks, then I can call this function. There's nothing happening in this function that I can't. I'm just saying, I'll create some refs. I'm creating a function, and now I'm creating a whole bunch of React elements, which you already know. I can just do this. There's nothing special about kind of creating these objects. I'm just saying create an object that's associated with this function and these values. So when a component is like this, you can just call it yourself. That's fine. Maybe you want to do that for a test. But as soon as we have hooks, now calling this function is not allowed. And that's because when we say react.useRef, React is kind of going, I have no idea, even though obviously we can see that this is inside this app function. React 1 doesn't know that this code is inside this app function. It doesn't kind of look at the stack trace or anything and see it's inside the app function. And even if it could do that, how would it know the difference between if I have, multiple to-do apps? It's still just the same function that's describing those to-do apps. So even if React could work out that this is being called inside this function, there's nothing. It would still need a way of knowing if that function is being used in multiple different places around the app. So this is why it's really key that when we render, this app here, we are just saying to React, here is a function that I'm giving you access to this function, and then React calls it. And because React's calling the function, it knows what was the last function it called. It knows I called this app function as a component, so it knows that this call is associated with that component, and then it can see, oh, it's been called a second time. It can keep count of the number of times the thing is called, and it also knows kind of which part of the kind of tree of components this is being referred to. So if I have a header and a footer, and for some reason I've got two to-do apps in them, like when I'm giving this structure to React, and React's kind of working its way through the structure, working out what it needs to do, it can tell, it kind of knows that it's processing this part. So when it's calling app here, and then when it's calling the app function again, it's not going to get confused. It knows kind of which part of the template it's currently rendering. So it can treat this function here completely separately to this and kind of give them their own state. So React comes along, it's working its way through things, it calls this app function, it sees ref is called once, ref is called a second time, and then goes in and gives all this return some more stuff and carries on working its way through. And when it moves down into the next thing, when it's rendering this header, it knows I'm onto now a new thing, and if header used hooks, it would know that to keep those separate. So that's very cool, and that's how this works. So you kind of need a component model for hooks to work. Like, it'd be very hard, in fact kind of impossible, to add hooks just to standard JavaScript, because you kind of need a way of structuring what these hooks are associating themselves with. Otherwise they would just be global and it wouldn't be particularly useful. So and then we can imagine, like, when the to-do app updates, React knows that this isn't the first time it's processing kind of this part of the tree of React elements. It can see that it's already, the last time it rendered there was an app, to-do app, kind of in this position, and it's now just, it can see, oh, this is the same function you gave me last time, so it knows that this is just updating. So when it sees this being called its first time and a second time, it can just line those up with the previous time they were called a first and second time. So that's how these things kind of work over time, how this ref here seems to have its own state from this one here. And because of the way this works, in that it's kind of, this is the first call to use ref and this is the second call to use ref, that leads to something known as the rules of hooks. These rules that have to be followed for React to kind of do this hook magic. So why are there rules and how you use this? Well, just as one example, if we say here, like, if so let's say there's some thing where we say, like, if date dot now is greater than some number, like if we're at some point in time, like if it's a Monday, if it's a Tuesday, then we want to do something differently, and I want to I only want to have a ref based on a certain condition. So getting an error here, and that's provided by, not saying it here, but it's being provided by ESLint. So ESLint is just scanning the code, and it can spot that we've got a useRef inside an if, and that's not allowed, because we could imagine that the first time this is created, potentially there could be 1, 2, 3 calls, and then when this updates, maybe we get a different condition here. This is now false, and then you get just 2 calls. So in that situation, you could think, oh, React, it just doesn't get the third call and it's fine. It just kind of forgets about it. But let's say if you had another one down here, now it could be ambiguous when you go, so I get this call, this one is called, and now let's say this was false the first time, so wasn't called, and then this one is called. So then it creates these kind of 3 slots. And then when the component updates, we go through and let's say, so now this call gets called, we call useRef, and it lines that up. Oh, that's the first call this component's making. useRef, oh, that's the second call, so we line that one up with B. Now let's say this one is now true. When it comes along, React doesn't know that this is on a different line to this. And again, maybe it could by looking at stack traces and a bunch of stuff, but that would require build tools to work and stack traces to be standardized, which they're not. So React can't tell the difference between all it knows is this is the third call to useRef this component is making. So it's going to incorrectly line this up with the previous one from down here, and now this useRef is going to return the ref that was actually created by this line. And then we come to here, and then it suddenly goes, what, this was previously there were 3 hooks and now there's 4. What should I do? Okay, you want me to create a state? So it could possibly do something there, but that doesn't really matter because we've already got a problem on that this one has now jumped in and stolen the previous kind of slot that this one was using. So even though it could potentially do something for this one, all it's going to do is create a new thing, and that, so if we'd stored something in this previous slot before, that's now going to get overridden by a new thing. So there's nothing really React, there's nothing nice React can do in this situation. So that's why you can't conditionally do something unless you're 100% sure that this is always going to be true forever. So every single time it renders, you're always going to get the exact same calls in the exact same order. But generally it's best to just not do this unless you're kind of got a more advanced use case. It's best to kind of follow these warnings. So this also applies for things like if this was a for loop. So you can't, if you had some state, if I wanted to create a ref for each to do, I can't do state ref dot current and then map each to do to have its own ref like that. Because again, this would, as I add more to dos, I'm now calling useRef more and more times or fewer times. They're not going to line up. So if I want a unique thing for each to do, then that's more for a job down here where I'm looping over my to-dos and I'm creating a new component for each one. And then inside that to-do, here I can say react.useRef, and then now there's kind of a unique slot for each useRef to use. So you can imagine, so even though there's only one line down here, it's mapping. So it's, this eventually, after this map runs, you end up with a structure, you end up with an array where there's a to-do. So you can conceptually imagine this is what I'm actually creating when I'm doing this map. So each component has its own slot in the tree of React components. So as React goes through and processes them all, it can call each one separately, and each one can then have its own space where React stores the hook slots. So that if you want to have like a varying number of refs, if you want to, I've got a ref and if I've got a hook and I sometimes want just 2 of those hooks, sometimes I want 10 of those hooks, you need to break them up and kind of spread them out and give each one its own component to live in. Great, we covered quite a lot there. So the docs are really good at explaining these kind of rules of hooks, and definitely recommend using the islint rule so that kind of your IDE can help point out when you're breaking the rules. And the docs in general about all the kind of aspects of hooks, really recommend reading. And we can say covered the kind of basics of hooks and useRef, and in future videos we will look at useState and useEffect. There are more hooks than this, but in this series we're just going to look at those 3 because they're kind of your core 3 hooks that are the ones that you really want to understand first. Thank you very much.